Okay, so we are on lesson 15, interpreting residuals from a line. Again, residuals are going to tell me whether my line of best fit is a good choice. And it's also going to tell me, hey, you might not have enough data, but it's not just going to be a linear line. Even though it looks right now like it's linear, it might be a quadratic, it might be an exponential. And we use residuals to find that out. So the first thing we have here is calculating predicting errors. Yeah, right. So the gestation time for an animal is the typical duration between conception and birth. So the longevity of an animal is the typical lifespan for that animal. Okay, so you've got the gestation, how long the mom is building that baby, to how long the years are. Okay, there's 13 different types here. We are able to make a scatter plot. There it is. Does there appear to be a relationship here? I would venture a guess and say, yes, there is a positive relationship. The longer the gestation period, the longer that animal lives. Okay, so it's positive. Could it be linear? I would again say yes. There is a positive linear relationship happening. So they substituted into a calculator all of those numbers. So they did stat. They cleared out L1, L2. They entered them in, and they ended up with this as their equation. Okay? The least square lines, the linear regression, has been added to the scatter plot. So this is the line of best fit according to the calculator. Still, so far, so good. It says, suppose a typical animal has a gestation of 200 days. Approximately, what value does the line, and then it stops, so it would be helpful if I had my notes here, which I do. Let me put my coffee down. It says, suppose, approximately what does the line value predict for the longevity of the type of animal? So the line predicts at 200, I've got something like, I'll say 13. So 13 years for my guess for number 2. That's my guess. And it's, again, just a guess. Would the value you predicted in exercise 2 necessarily be the exact value for the longevity of that type of animal? Well, no. Could the actual longevity of that type of animal be longer than predicted? Sure, it could. Could it be shorter? Sure. It's a prediction. This is the line of best fit. If you notice, when we go back to this graph, there is not a single actual value on this line. These are predictions for all the animals. Based off of what we have, this is the best guess that scientists, in our case, mathematicians, came up with. But this is what scientists do. They use lines of best fit. So you can investigate this further by looking at types of animals included in the original. Okay, so we know the lion. Its gestation time is 100, and we know that it lives for about 15 years, which is right here. The least square lines is 10 and 6/10. So how close is it to being correctly? More precise, how do you have to add to 10.6 to get the lion's true longevity? So this is a vertical line regression model. Okay, this is a vertical line regression model. It's showing exactly how far from this line to the actual value it is. What if I drew the line down? Would I have a positive or negative? If you're saying, well, Mr. H, that's a dumb question, you're right, it's going to be negative. So if I have to draw that line down, you could have a vertical regression down. So let's continue to look at this. We're going to do a lot of this in class. Repeat this for the sheep. Okay, again, it is important to know the residual is actual minus predicted. So our residual, and I think I called it wrong, I think I called it regression. The residual value of that one was positive 4 4/10. The baboon residual, its actual is 20. So how would I find the best fit? Well, I'd say 20 minus 5.9 on that line. It's going to give me 14.1. Okay? So it's showing me positive residuals. It's showing me negative residuals. But notice, it's not showing me a residual of like 17. If you predict something and the residual is off by like 17, it's probably not a good guess. And that's what it's saying right here. The predicted longevity is 17.4. Think about what the actual longevity of this animal might be. Could it be 30 years? Well, 30 minus 17.4 is like 12.6. Let's go back up to our residuals. Does 12.6 show up at all? Would that make sense? Well, no, that's too far away. Just like our deviation, it's too far away. So it's probably not going to be 30, and it's probably not going to be 5. So judging by the size of the residuals, what values do you think could be reasonable? Well, we're within 5 or 6. So I'd say, okay, let's subtract 6 from this. So it could be between like 11. Let's add 6 to that. And it could be to about like 23. Those are fair numbers. So between 11 and 23, that's much fairer than saying 30 and 5, based off of the residuals. So residuals are what's giving us the basis of our best guess. Okay? So when a least squares line is used, that's our linear regression line. Its residual is actual minus the predicted. Residuals are the vertical distances away. You will use these to make guesses. And we're going to, again, use a couple things. I'm going to try to do some things in class where we make our own line of best fit, and we're going to use residual facts as well. The next one shows residuals that's going to help us tell whether it's going to be linear or nonlinear. Residuals are importante. Let's see. Have a good one.